start talking about asymptotes and limits. Everything so far with the limit, we've talked about a limit approaching a finite number. Today we're going to talk about a limit approaching positive or negative infinity. So instead of approaching 7, we're going to say what's happening as it's approaching larger and larger values. And so hopefully you know this. Infinity does not represent an actual number. It's more about what's happening as x is getting bigger and bigger or smaller and smaller. So we say the limit of s as x approaches infinity. We mean what happens as you get further and further. Kind of almost like that. Here. That's just from your textbook. It's probably not even open ever. So we could also go back to the good old sandwich theorem here. And we can talk about finding the limit as x approaches infinity from this. Alright, so it says, graphically and using a table of values. So let's think about a table of values first. If before we were picking a table of values, like we were getting really, really close to 1, we would pick like 0.9, 0.99, 0.999. I want to go to infinity, so what can I pick? What do I pick, right? So this is what I always pick. I start 10. If I pick 10, I want to know what's happening. That's not really good. And then I pick 100. And then I pick 1,000. If you really need to pick 10, you probably just start with 100, 1,000, 10,000. I always just try to pick numbers that I can just plug in and see what's happening in that problem. With a calculator, we can just plug this in, and we will just plug it in a minute. But without a calculator, just think for a minute what's going to happen here. When I plug cosine of 10, that's not really a number you might even circle. But what is the biggest that cosine can ever be? 1. So no matter, like, we're thinking about this, that's the biggest it could ever be is 1. We'll actually plug it in and see what we get in a minute. But on the bottom here, if I plug 10 in there, I'm going to actually get 10, right? We're going to get some number on the top between negative 1 and 1 over 10. So I'm going to just put, like, question mark over 10 right now. And if I plugged 100 in, even if I plugged in cosine of 100, do you agree that the biggest I can ever get is 1? So, like, it's not really 1, which is going to be some decimal, but the biggest it could ever be is 1. The biggest this could ever be is 1, and then I would get 100. And if I did the same thing with 1,000, do you agree the biggest again on the top could be 1? What's happening to these numbers? As I take bigger and bigger values of x, what's happening to these values that I'm going to get? They're definitely getting smaller and smaller. They're approaching what value? 0. So without even asking the exact calculator, it looks to me like this is approaching 0 as x is approaching infinity. But I'll plug it in to be sure. Just for fun. So this was actually negative 0.083, like the whole thing. Then this goes on. Then this is 0.0086. And then it goes to 1,000. And again, I'm in radians, not degrees here. I got 0.0005. It's kind of like when we made the table of values before, looking at our limits. You hope that it's approaching some specific value there in that problem. We didn't really use it. Alright guys, so I stopped talking about what it's approaching. Remember how we would start if we were going to do the sandwich theorem? And then I needed divided by x. So I would divide by x here, divide by x here, and divide by x here. This would have been way easier with our table. I wouldn't have to worry about the cosine stuff, but that's the thing. We could still have done it without the table. The idea is you know what happens at 1 over x. Maybe you don't know. Do you remember what the graph of 1 over x looks like? a good old rational function. Like there's two pieces, right? Like this. Like it's like this, and it's like this. And again, we could think about, we wouldn't have even need this. If we were making a table for 1 over x, you would get like 1 over 10, 1 over 100, 1 over 1,000, 1 over 10,000. But hopefully you realize that as x gets bigger and bigger, that y value is getting closer and closer to 0. And the same thing's happening on this side. As x is getting towards negative infinity, it's getting closer and closer to 0. So we could say the limit as x approaches infinity of negative 1 over x equals the limit as x approaches infinity of 1 over x, which equals 0. It always happens when I'm over here, so it's something over here. Somehow I must click, like, change colors. I don't know. It doesn't happen. But the limit value is what is getting closer and closer, right? Like, as I'm approaching. But you're right, it's an asymptote, and that's the big idea here with limits going to infinity. It will always be that horizontal asymptote. Well, it just what it asks you. So, like, just like sometimes it's going to ask you what's happening just as I'm going towards positive infinity. Sometimes it's going to ask towards negative infinity, and sometimes it'll say plus or minus, and actually want to do those. Most of the time.
Please report in the comments. Also, could all 8th graders, A through M, 8th graders, A through M, report to the comments.
Most of the time, you just have one horizontal asymptote. Think about all the functions we did. We've never had more than one horizontal asymptote. But when we get into E stuff and ln stuff and fractions that have E in them, then there could be positive infinity might get you something different than negative infinity. Absolute value, positive infinity might get you something different than negative infinity. So we will talk about that. But it's all about what this says. So since this doesn't say plus or minus, they're really only asking what's happening as I'm going into that direction. But you're right, I see. Okay, so Sabrina already said this, that this was the asymptote. Last year in pre-calculus, we didn't really talk about limits. We talked about if a polynomial function has a horizontal asymptote, we could look at the degree of the numerator compared to the degree of the denominator. Remember those awesome rules? I think maybe I covered some stuff up on your slides, but I didn't on this because I couldn't find it. But remember, if you have a rational function, the numerator over the denominator, you look at the degree of the numerator and the degree of the denominator, which is like the highest exponent at the top, the highest exponent at the bottom. If the degree of the numerator is less than the degree of the denominator, just like good old 1 over x that we just did, there's no x in the top, but there's an x in the bottom, then that's where you always get y equals 0, just like we just saw. So if you know that, because x is getting bigger, the top's staying the same, that's why it's going towards 0. Remember, if the degree of the numerator is equal to the degree of the denominator, you take those leading coefficients. So, like, if you had 4x squared plus 1 over 3x squared minus 7, the horizontal asymptote, which is now the limit as x is approaching infinity, would be y equals 4/3. So it really could be any number. And sometimes, if the degree of the numerator is bigger than the degree of the denominator, there isn't a horizontal asymptote. So what does that mean in terms of infinity? It means that as x gets bigger, y just gets bigger. And just think about something that you know, like a quadratic. If you want to think about numerator and denominator, think about that would be like x squared over 1. The degree of the numerator is bigger than the denominator. If I keep plugging bigger and bigger values of x, do you agree I just keep getting bigger and bigger values of y? So the function's just growing without bounds. That's what happens when the numerator is bigger than the denominator. There is no horizontal asymptote, which means there is no limit as x approaches infinity. So the big thing that I want you to realize is that horizontal asymptotes and limits approaching infinity are related. And so this is kind of the big definition here. That if you have y equals b is a horizontal asymptote of a function, if you have a horizontal asymptote, then the limit as x approaches infinity has to equal that b value or the limit as x approaches negative infinity has to equal that b value. So what happens on the AP test is they give you a question that says, find the limit as x approaches infinity, some crazy rational function. The idea is you see infinity and you think, oh, that's just an asymptote. I can just look at the leading coefficient and you're done with that problem. But you have to know this rule. This is good, because we'll stop with horizontal asymptotes today and talk about vertical asymptotes tomorrow. And maybe by separating it, we won't get something confused is what I'm going to say. So it says, use the graph and a table to find the limit as x approaches infinity and as x approaches negative infinity. Identify all horizontal asymptotes. And again, this is kind of just to try to make that relationship of if you have limits at infinity and negative infinity, then you should have horizontal asymptotes. If you don't have limits at infinity, you should have no horizontal asymptotes. So you can look at the graph here. Maybe you're not really sure what's happening. We could make a table. We could do that too. But what we really want to do is, especially in a rational function, we want to remember those shortcut rules of looking at this. The degree of the numerator is the same as the degree of the denominator, which means what do you know about the horizontal asymptote of that function? It's y equals 1. So for part C, identify all horizontal asymptotes. Remember, it's an equation. You would say y equals 1, because you could look at those leading coefficients. They're the same. It's 1 over 1. Then we can kind of go back to the limit part. This is saying the same thing. What's happening as x is getting bigger and bigger? You can kind of see here, right? If this is my line, y equals 1. It's definitely approaching that. We could make a table and it works that way. But the limit as x approaches infinity of f of x is also going to be 1. It's not y equals 1, it's just the value. And the same thing over here, what happens? The arrow and the negative sign, when they type it, it's like all 1. So just be careful. But that is arrow negative infinity. Again, most of the time, the limit as x approaches infinity is going to be the same as negative infinity. And it's also going to be 1. So, limit at infinity for the last. Alright, so I picked some questions on your homework. I picked some tricky ones on purpose. I picked some absolute value ones. And I picked maybe there's an E one on there that we can look at. You can't do all of your homework because what we didn't get to today is talking about vertical asymptotes and how limits apply to those as well. So you're welcome to look at some of your homework tonight. You're welcome to just wait if you want, and then tomorrow we'll finish this. You should have a good enough class tomorrow to work on your homework for your class because you just have like half of those tomorrow. Okay? And I'll post some videos if you're still